everyone, and welcome to MathSux. This video is going to help you pass the Geometry Common Core Regents. We're doing this one question at a time. Here is question 32 with part 3. A building is composed of a rectangular pyramid on top of a rectangular prism, as shown in the diagram below. The rectangular prism has a length of 38 feet, a width of 15 feet, and a height of 22 feet. The rectangular pyramid sits directly on top of the rectangular prism, and its height is 12 feet. And then we have our diagram, and then let's look at the questions asking. An air purification filter was installed that will clean all the air in the building at a rate of 2,400 cubic feet per minute. Determine and state how long it will take to the nearest tenth of a minute for the filter to clean the air contained in the building. So there's a couple steps to this question, but it's pretty straightforward, which is good. We're going to need to find the volume of this whole shape, and we're going to do that by finding the volume of the rectangular prism first, which is just going to be length times width times height. So I'm just going to draw out the side. Times 22 times 15. So when you plug that into your calculator, you'll get 12,540. So that's the volume of the rectangular prism. So let's get the volume of this rectangular pyramid. So this is going to be length times width times height all over 3. So be careful here because this is a different shape, so it has different measurements. So I'm going to draw that on the side again. So they said the height is 12 feet. Says it over here, and then the other measurements are going to be same as the rectangular prism. So 38 is going to be 38 feet, and then this is going to be 15. So to find the rectangular pyramid, we're going to do 12 times 38 times 15 all over 3. So plug this into your calculator and you'll get 2,280. So now we can add these two volumes together to get the volume of the whole thing. So when we do that, we'll get 12,540 plus 2,280, which is equal to 14,820. So this is the total volume of this shape. But that's not what they're asking for. So this is where we're going to do the third part of this question. If you look, they're asking for how fast this will take to filter the air. So they give you this rate, and what we're going to do, we're just going to divide our volume of the shape by the rate. So we're going to take 14,820, the volume of our shape, and then divide it by the rate they gave us, which is 2,400 feet per minute. We're going to get 6.175, and if you go back, they wanted it to the nearest tenth. So we're just going to have to round up to 6.2. That's our answer. Question number 33. Given triangle ABC, triangle DEF, AB is perpendicular to BC. So I'm just going to start filling these in as we go. So it says AB is perpendicular to BC, and BC is perpendicular to DE over here. And it also says AE is congruent to DB over here. And lastly, it says AC is parallel to FD. And then it wants us to prove triangle ABC congruent to triangle DEF. So let's look at how we're going to do this. Notice we have a right angle right here and a right angle right here. So already we have an angle. This is congruent to this, and then this they share. So we know that we can prove that these two sides are congruent to each other by doing the addition postulate. So I'm just going to highlight that. We have a side. And they also mentioned that these are parallel. So that's going to give us some equal angles. Because these are parallel, line AD is going to act as a transversal, making angle A congruent to angle D. So we're going to have an angle, a side, and an angle. So we're going to be proving these two triangles congruent by angle, side, angle. And if this doesn't make sense, don't worry. We're going to go over each step. So the first thing you're going to want to do with any kind of proof is just start with the given. So 1, and then we're just going to say everything they gave us. And our reasoning for this is it's given. So here we can start with the right angles. It feels nice and easy to start with. So I'm going to say angle DEF. We already know that they're right angles. That was given to us because they're perpendicular. So angle DEF is going to be congruent to angle CBA. And our reasoning for this is that perpendicular lines form congruent right angles. I'm going to highlight the colors we're using. So the right angles are pink, so I'm just going to color this in pink so it's easy for us to identify what we're doing. Obviously you wouldn't do that, you don't have to do that on a test though. Okay, next step, so we got our angle, our right angles. Next we can, let's do this side. So the first thing I'm going to mention is this reflexive point of this little side they share, EB. So I'm going to say EB is congruent to EB, and this is going to be based on the reflexive property. And then we're going to need another statement saying that AB is equal to ED. So first we're going to say AE plus EB is equal to BD over here plus EB, that same piece of length they share. So we have AE plus EB is congruent to BD plus EB. So because of that, we can say that AB is congruent to ED. And we know this because this is the addition postulate. Again, I'm just going to color this in, so we used a nice purple here. So I'm just going to color this in. We needed 2. This is where we're going to talk about those angles that form because of parallel lines being cut by a transversal. So we're going to say angle CAB is congruent to angle FDE. Right? CAB to FDE. And this is based on parallel lines cut by a transversal. And just to keep track of where we are, we're at these blue angles, A and D. And now finally we could actually just prove these triangles congruent by angle side angle. So triangle ABC is congruent to triangle DEF by angle side angle. So that's our answer. Question 34. In the diagram below, a boat at point A is traveling towards the most powerful waterfall in North America, the Horseshoe Falls. The Horseshoe Falls has a vertical drop of 188 feet. The angle of elevation from point A to the top of the waterfall is 15 degrees. So you can see this is kind of like a wonky looking right triangle. A little funky looking, but it's a right triangle. After the boat travels towards the fall, the angle of elevation at point B to the top of the waterfall is 23 degrees. So it's saying over here, this is 23 degrees angle of elevation from point B. Determine and state to the nearest foot the distance between the boat traveled from point A to point B. So they want to find the distance over here from point A to point B. They want to know what this is. So if we look here, there's really 2 right triangles going on. So we know if we have right triangles, we know we're going to be dealing with SOHCAHTOA trig functions. So to start off, I'm just going to draw out the 2 right triangles we're going to be working with. So notice we have this bigger right triangle on the outside starting at point A, which has an angle of elevation of 15 degrees, and the right angles over here, and then it has a height of 188 feet. And what this distance represents over here is this entire thing. So this entire distance. We want to find the values down here, right? So I'm going to put an X here So we'll call this X. And then the other triangle we're going to be working with, the smaller triangle over here. I'm just going to draw that out also. Right, and then it has this angle of elevation at 23 degrees. The right angle's over here in the same spot, and then this has a height of 188 feet. Let's call this distance from B to the right angle, let's call it Y. Okay, so now we kind of marked out all the information we can get out of this thing, and now we're going to have to use our trig functions. So first, let's look at this bigger triangle and let's find the value of this X value here of the whole length of the boat to the waterfall. So in relation to this angle, we have its opposite, and then we're trying to find its adjacent. So we're dealing with the opposite and the adjacent. So if you look at our values, we're going to be dealing with tan. So we have tan of the angle value, which is 15 degrees, is equal to the opposite, 188, over X, which we don't know. And now we just need to do some algebra to figure this out, so we could cross multiply. And we could plug this into our calculator. And we get this big number. So I'm just going to mark this off. So this X is equal to 701.625518. So this is the total value of this entire length of this thing. Okay, so now we did that. So let's look at our smaller triangle and figure out this length over here. So again, we're going to look at the angle and see what information we have. So in relation to this angle, we have its opposite, and then we're looking for its adjacent. So we have the opposite and adjacent, so we're going to be using tan again. So very similar, we're going to do tan of 23 degrees is equal to the opposite, 188, all over y. And again, we could just cross multiply and solve this. Plug this into our calculator. And we get y is equal to this number, 442.900248. 442.900248 represents this length from B to the waterfall. So now that we have these two values, remember what they were actually looking for. They wanted the values from A to B. So since we now have these two values, the value of the whole length, 701, and then the value of B to the edge, notice we could just subtract them to get what they're looking for, AB. So we could take the whole 701.6255518 and then subtract out that other distance that we found, 442.900248. And let's see what we get. So we get this number, 258.725307. And we get this long number, but they always want this rounded to something. So this time they want it rounded to the nearest foot. So you can see that we're just going to round up to 259 feet. And that's our answer. Question 35, our last question. Triangle Joe has vertices whose coordinates are 4, 6, -2, 4, and 6, 0. Prove that Triangle Joe is isosceles. So isosceles, we know, is a triangle with two equal sides. So that's what we're going to be trying to prove here. We're going to be using the distance formula to prove that this triangle has two congruent sides. So the first thing I'm going to do is just sketch out this graph. They give you a coordinate graph on the next page too, but I'm just going to do it on this page. Now I'm just going to put all these points together. So we want to find the distance of all these sides. So it looks like these two sides are going to be equal to each other, but we'll see that as we go along here. So just a reminder what the distance formula is. It looks something like this. So we want to measure at the distance between each point to find the side length of each of these. So let's start with O and J and see the distance between these 2 points. So I'm just going to take O and the coordinate point associated with O, -2, 4, and then J, 4, 6. And then I'm just going to plug in numbers into this formula. So we're just going to do x2 minus x1, so we'll go this way. And then the same thing, 6 minus 4 squared. So we get radical 40. So over here, OJ is radical 40. So I'm just going to put that over there. So now let's do the next one, JE. And then plug it into the distance formula. And you see that we also get radical 40. So even though, so these two sides are congruent, let's make sure that this side is not congruent. So if we get a radical 40 here, this is not going to be an isosceles triangle. So let's make sure it isn't, and let's take these 2 points O and E and do the distance formula again. So you can see that this last distance over here is going to be radical 80. So we know that this really is an isosceles triangle because these two match and this one is different. So we just need to write a little sentence about that based on what we found here. So here we're saying the distance measurements of triangle Joe has 2 congruent sides, therefore triangle Joe is an isosceles triangle. So that's our answer for the first part of this question. So let's turn the page because there's more to it. Okay, so next part of this says point Y22 is on AE. Prove that JY is the perpendicular bisector of OE. So first, I'm just going to draw this out again over here so we can look at this easier. So just filling in what we found in the previous question, we know that the distance over here is 40, this is 40, radical 40, and then this is radical 80 down here. And then now we can take a look at this question and see what it's asking, now that we have it a bit more set up. So it's saying point Y22 is on OE. So here's OE. So I'm just going to mark what they said, 22. So point 22 is over here. So this is point Y is on AE. Okay, prove that JY, so they make a line here, JY is the perpendicular bisector of OE. So we need to prove that JY, this line, is a perpendicular bisector. It's going to make a right angle, and it's also going to make OY congruent to YE. So there's 2 things that we're going to have to prove here, right? Because there's 2 things that happen with a perpendicular bisector. So we're going to need to prove 2 things. We're going to need to prove that OY is congruent to YE. And we're also going to need to prove that there's these right angles here. So we're going to have to prove JY is perpendicular to OE. So let's do this one step at a time. So let's focus on the first one. Let's do OY congruent to YE. So we can do that by using the distance formula again. So we want to prove OY is congruent to YE. So we're going to have to find the distance of each of these. So we're going to do this. So let's do OY first, where O is negative 2, 4, and Y is 2, 2. And we just need to plug these values into the distance formula. So we get radical 20 for this part, OY. I'm just going to fill that in, radical 20. And now let's find the other part, YE. This is E over here. We'll do the same thing, the distance formula. These two are equal to each other. But we're still not sure if it's a perpendicular bisector because we need to make sure, we check this off. So we still need to prove that JY is perpendicular to OE. So to do that, we're gonna need to find the slopes of each of these lines. Their slopes are negative reciprocals of each other. So let's find the slope of JY first. So J is 4, 6, and Y is 2, 2. And the slope formula, if you remember, is y2 minus y1 over x2 minus x1. So let's do that. We have 6 minus 2 over 4 minus 2. And we get 4 over 2, which we can reduce to 2. Okay, so that's equal to 2. We're not sure if there are negative reciprocals yet. The only way we could find out is to now find the slope of OE. So let's do that. So O is negative 2, 4. And E is 6, 0. And we're going to do the same thing, the slope formula. So we can reduce this and we'll get negative 1/2. So now, looking at the slopes, you can see that they are negative reciprocals of each other. 2 is going to be the negative reciprocal of negative 1/2 because we flip and negate it, right? So this line, JY, is a perpendicular bisector of OE. So now we just need to write something about that. So we could write something about it here. So for this part, the first part we found, we can say that OY is congruent to EY, JY is a bisector of OE. And then for the second part, we can say since slopes are negative reciprocals of each other, OY is perpendicular to JY. And that's our answer. So there's like a lot of work, but the formulas are all pretty easy. You just have to understand what has to get done here. So we covered both our bases in this question. This is the end of our test. If you have any questions, please let me know. Thanks so much for stopping by. Good luck and happy calculating. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!